All right, guys. I'm curious. Talk to me about these. Again, we're not actually going to solve them. We're going to talk about whether or not it's possible to solve them, and we're going to refer to the structure of it. So, like, what operations are happening? If you were going to undo them, are you allowed to do that? That's what I mean by looking at the structure here, okay? So on number 1, if I had asked you to solve that, what would you do first?
11 minus 5.
11 minus 5. You'd subtract 5 on both sides, right? Is it possible to do 11 minus 5?
Yes.
Yes. So that's valid. What would you do after that?
And then I would
3 by 6.
Yep, then we would divide. Is it possible to take whatever we get after subtracting and divide that? Yes. So this one does have an answer. This one does have a solution. Just out of curiosity, even though I know the directions said not to solve it, did anybody solve this one?
I did.
What did you get? 2. X is 2. So this one has one solution, right?
Yes.
Number 2. Again, we're looking at the structure and whether or not things are possible. What would be your first step in solving this one?
No. It's a square root. So I would do the box thing, right?
You
Oh,
could.
Yeah, we will subtract 10.
Subtract 10 from both sides. Is that valid?
Yeah.
Yes, we are allowed to do that. Okay. What would you do after that?
The box thing. That's what I would do.
The box thing.
Yeah.
So talk to me about the box thing. If you were going to set this up in the box, what would go here?
I don't really know how you do the box thing anymore, but I know that's what I would do.
Fair enough. Does anybody remember how you would do it? Yes, ma'am.
It would be
X squared would be here.
the only diagonal from it is 10.
Close. What did we say we would do to both sides?
Oh, yes, subtract. It would be 9.
Yeah. So 1 minus 10 would give me not 9. If I have $1 and I want to buy something that costs 10, this would be a negative 9. So then the question becomes, could you find two numbers that multiply to give you negative 9, but when you add them together, they cancel out? What two numbers would multiply together to give you negative 9?
Negative 3 and 3.
Negative 3 and positive 3 would do that. So it is possible for us to come up with this. So this would be another yes. X equals 3, x equals negative 3. I know I asked you not to solve them, but as we're talking through it, I think it's important that we point out what some of the solutions could be here. So this one has 2 solutions. So I knew all the way back at the beginning we were going to have 2 solutions. Do you know how I knew that? X is squared. Whatever my highest power is, that's the number of solutions I've got. Would there be another way without the box thing to go about solving this? We could use quadratic formula. Is there anything else that we could have done as we talked about steps that we would take to solve it? I heard square root. What would I want to do before we square rooted?
Gianna? You talking to me?
Nope.
What are you looking at?
I was looking at Niles.
Oh. Sorry.
That's okay.
I can't see Gianna.
I wouldn't subtract the 10 if I was going to do a square root.
Yeah, that did sound funny.
I would subtract the 1.
Oh, my bad.
I would subtract 1 from both sides, which is valid, and then I could do a square root of both sides. You got to be careful about that, though, because we should still end up with 2 solutions if we do that. So a better way to think about it, rather than just do the square root, is what number could I take and multiply by itself and get 9? Because I could do that with both a positive 3 and with a negative 3, right? Over to number 3. Let's think through this one because it's very similar in structure to number 2, right? Does this one have a solution? I'm seeing some head shaking over here. Tell me why. What did you see?
If you try to solve it, you can get negative 10 equals x squared. Nothing times by itself can get negative 10.
Love it. I'm only going to disagree with you on one point, and that is if I subtract 9 from both sides, I'd get negative 8 instead of negative 10. But all the rest of your explanation absolutely still holds. There is no number that I could take and multiply by itself and get negative 8 as the output. Because if I'm multiplying something by itself, it has to be what type of number is the output.
Positive.
Has to be a positive. So this one is our first no. Nothing times itself gives me negative 8. So that would be a no. I had somebody ask me earlier today, and it was a great question. They said, are we including imaginary numbers? Because if we include imaginary numbers, then it is possible to do that. In this class, we don't deal with imaginary numbers. So if it's not a real number, then we're not going to deal with it. That's this semester and next semester. Like, we don't deal with imaginary numbers at all in here. What about number 4? Is there something that we could put in for x? Same thing on both sides, and we would get both sides to come out to be the same. Too much math? That's a problem. We're in a math class.
Can we put 2?
Well, let's try it. If I put 2 in the place of x, what would that give me here?
6.
6 minus 5 would give me 1. Over here, I'd have 6 plus 6.
12.
1 and 12 are not equal. So 2 doesn't work. Thoughts for a negative? What negative number should we try?
1.
Negative 1. Okay, if I put negative 1 in right here, what would I get?
Negative 3.
Negative 3 minus 5.
I said 4. Negative 4. Negative 3 minus 5.
Negative 3 minus 5. So if I'm standing at negative 3 on the number line, and then we go 5 units to the left, negative 8. If I put a negative 1 in over here, I get negative 3 plus 6, which would give me a positive 3. Not equal. If I were to ask you to solve this, what would we need to do first? What's different about this one than all the others? Yeah, I have x's, and I've got them on both sides, right? So the first thing I would need to do if I was going to solve this is to get all my x's on one side together. Taylor, help me out. What would I need to do to get my x's on the same side? Looking at number 4 right here. What would I need to do to get the x's on the same side? Yep. I could do minus 3x. And if you do it to one side, you got to do the exact same thing to the other side, right? What would happen right here? It's going to cancel. What would I be left with? This is like 3 apples, take away 3 apples. So how many apples do I have left? None. If I had 3 and I took all 3 away, now I have none. So that would just be 0 minus 5, right? What's 0 minus 5? Negative 5. You said if I do it to one side, I got to do it to the other side. What would happen here? Cancels out, and that would mean what? It's going to be a 0 again. If I cancel the whole thing out, I've got none of them left anymore. So that would be 0 plus 6 over here. What is 0 plus 6? Do I have any x's left at all? No, my x's all canceled out because they were the same on both sides. So when I took it all away from one side, it took it all away from the other side. Is this true? So is there anything that I could put in for x that would ever make these two sides be the same?
No.
No. So this is a no. My x's canceled. And negative 5 is not equal to positive 6. So when my x's are the exact same on both sides, the only way this could actually come out to be equal is if these two were the same. Because then it would be true, right? What about number 5? What's going on with number 5 that we haven't had to deal with yet? Fraction, a denominator. Whenever you see a fraction, when you see a denominator, what operation is happening? Division. So if we were going to solve this, we want to undo that division, right? What operation undoes division? Multiplication. So if I were going to walk through solving this, I could multiply both sides by 3 plus x. Correct? Am I allowed to do that according to algebra? If you do it to one side, do it to the other, does that work with multiplication? Yes. So that would cancel this out. I would have 3 plus x equals x plus 4. Does that look more like number 4?
Yeah.
Does a solution for this exist? I'm seeing some head shaking. Edgar, why did you shake your head?
Because you just cancel out the x's on both sides and 3 doesn't equal 4.
There we go. These x's are exactly the same on both sides. So if I take it all away from one side, it's going to take it all away from the other side, right? Those x's are going to cancel each other out. And I'm left with what? 3 equals 4. Is that true? No. So this is another no for the same reason that number 4 was no. The x is canceled. And 3 is not equal to 4. Number 6 looks a lot like number 5. Does that just automatically mean that it's a no? What would I do if I was going to solve this?
Multiply.
I can multiply. What would I multiply by?
2x minus 2.
2x minus 2 by my denominator. And so I would end up with x minus 1 equals 2x minus 2. Are my x's going to totally cancel each other out like before?
No.
Why not?
Because there's no coefficient.
Yeah. One of them has a different coefficient than the other. Coefficient is the number in front of my variable. Here they canceled out because it was 3 x's and 3 x's. They were the exact same. Right here, same deal. 1x and 1x. So they cancel each other out. How many x's do I have on the left side over here? 1. How many x's over here? 2. So if I take all of these away, what would I still have over here? I'd still have 1 over there. Would it be possible to find a solution for this one? As long as my x's don't completely cancel out, yes, I can. So this would be another yes. Did anybody by any chance go through and solve this?
No, sorry.
I'm curious. What would the solution be? Since we know we can solve it, let's go through and solve this one.
Would it be 1?
Let's see. 1 minus 1. 2 minus 2. I can find a value for x. What happens if I put it back into that fraction, though? What happens if I put a 1 up here?
It's gonna cancel,
Makes a 0. What happens if I put a 1 down here?
it's gonna cancel, make zero.
It's going to cancel and make a 0.
Undefined,
Undefined, why?
indefinite.
Tell me why. I like it.
I don't know, I just think.
No, tell me why you were saying that, because you were right on. What did you see that made you like pop up with undefined?
Because 0 over 0 is undefined.
Yes.
You don't get anything?
So no 0 in the denominator. So when I set it up like this, it looked like I could solve it, right? But then when I took that value for x and I put it back in, it came up with something that makes Siri cry. If you ever ask Siri what 0 divided by 0 is, she'll tell a very funny story.
I learned it.
We can do it in a minute. We will have some extra time. I promise. I promise. What I want you guys to do next, though, I'm going to give you probably about 5 minutes or so to work on it. You're welcome to work with a partner if you want to. Same kind of deal. Do not actually solve these equations. I want to know which of these 5 equations would have the same solution. Which one of these would have the same solution? Look at the structure. Look at the structure here. Do you guys remember in the last unit when we were writing equivalent expressions? So if I had an expression that looked like this, I know that that means the same thing as this, even though they look different. So any of the things that I would do through the course of solving an equation, if it makes it look exactly like another one, then they would have the same outcome. They would have the same solution. So look for that structure. I'm going to give you guys about 5 minutes. Work with a partner if you'd like. Work on your own. You can think about the steps that you would take to solve it. All right. So I'm curious, did anybody find 2 of the equations that would have the same answer? All right. Which 2 did you find? First 2. Give me a quick thumbs up, thumbs down. Do you guys agree or disagree that the first 2 would have the same answer? Awesome. What could I do to the first equation to make it look exactly like the second equation?
Subtract 1.
Subtract 1. Just like this? On both sides. When you do it to both sides, guys, if you have your books with you today, open them up to pages 106 and 107. If we do the same thing to both sides, that is a property of equality. What did we do to both sides here? Subtract. This is the subtraction property of equality. Pages 106 and 107. I do not expect anybody in this room to memorize all of those things. You do not have to memorize these. But honestly, you probably know all of them already. You might not know their official names, but these are all the ways that you've already been working with numbers. In Algebra 1, in Algebra 2, all the things that you learned about how equations have to stay balanced, those are all properties of equality. The 2 sides have to stay the same. If you do it to one side, you do it to the other, then you just tell me what operation did you do. Subtraction property of equality. I can make these two look exactly the same, so I know they would have the same final answer, the same outcome. So far, so good? Are there any others? If you see one, tell me just one that you know would have the same answer as the first two. Yes, ma'am. 2x plus 2 equals 6. This one also has the same answer. Now I'm curious. What could I do to 2x equals 4 to make it look exactly like this one right here?
Add 2 on both sides.
We could add 2 on both sides. If I added 2 and I added 2, I would have 2x plus 2 equals 6. And now they are identical, right? I don't have to solve it all the way to see that it would have the same answer. If I can make the equations identical, then I know they would have the same answer without knowing what the answer is. What do you think we would call this property? Still subtraction property of equality? You're absolutely correct. This is the addition property of equality. We added to both sides, and so this would be the addition property of equality. Are there any others that would have the same answer? We've only got 2 more.
Okay, those both, none of them are related to those. The last 2 are related to each other.
You think the last 2 are related to each other?
Yeah.
What do you see that makes you think these 2 would have the same solution?
Okay, so basically, you kind of won. Okay, so basically, I flipped it because looking at it like that kind of hurts my eyes. So
Mhm.
I flipped it to 2x minus 5 equals 1. And you would add 5 to the negative 5.
So question, 2x minus 5 equals 1. Are these the same? Because if they're the same, then I'm allowed to do that. If they're not the same, then I can't do that. What could we do to test to see if they were the same?
Solve it.
We could solve it, or we could do what? We could substitute, right? Do you guys remember for some of the ones that we're like, I don't know exactly what to do with this, we could always pick out a value and substitute in, see if it comes out the same. So what about if I put 5 in the place of x? Let's just pick out a test number. I literally just pulled that one out. If I put 5 in the place of x, in the top equation, that would be 1 equals 5 minus 2 times 5. What's 2 times 5?
10.
So 1 equals 5 minus 10. Let's not even deal with the 1 equals part. Let's just look at the one side. That would give me negative 5, right? For the way we've switched this around, where it's written in purple, 2x minus 5, that would be 10 minus 5. Does that also give me negative 5? That gives me what? Positive 5. So these are not the same. So we can't switch it around like that. You could switch it around if you keep the signs with the coefficients. So instead of 2x minus 5, if you wanted to rewrite it as 1 equals, is the coefficient in front of the x a positive or a negative? Negative, because it's minus 2x, right? So I could rewrite that as negative 2x. Is the 5 a positive or a negative?
Positive.
5 is a positive. That is allowed. That is allowed. Look at your sheet. See if you can figure out what property. Let me do that. What property lets me move those pieces as long as I take the signs with them? It's not necessarily a property of equality because we didn't do things on both sides. Good question. This is going to be something that's on page 106. What lets me do this? As long as I take the sign with it. What let me switch things around? What property lets me switch those things? Yes. Thank you.
Thank you.
Yes, this is the commutative property. It's a little bit easier to see if I write it like this because commutative property doesn't work with just subtraction. That's why we couldn't just flip it around. But if I take the sign with it, so if I rewrite it as 5 plus negative 2x, then I can use the commutative property. Nice work. I did not expect that one to come up today, but this was a great opportunity to look at it. So, question, Gianna. Do you still think these two have the same answer?
I thought we just did it.
I'm sorry, you thought what?
I thought we just did it, so that means it couldn't have the same answer.
And that's okay. And I didn't do any of that to call you out. It was a great investigation into what's going on mathematically. I loved being able to look at that, and that wouldn't have come up if it wasn't for your comments. So thank you for that. I'm curious. This fourth one over reminds me of one of the ones that came earlier. It reminds me a lot of the very first one. Look at that very first equation. What could I do to that very first equation if I wanted to try to make it look like the fourth one? Subtract what?
5.
Subtract 5? Well, my 5 is not negative here, so I don't know if I'd want to subtract 5. What has a different sign on it? The 2x. Where is the 2x on this one? Is it on the left or on the right? It's on the right. Over here, it's on the left. Can you think of anything that I might be able to do there? I can subtract 2x from both sides. What would that make it look like then? 1 equals 5 minus 2x. Does that look exactly like the fourth one? Am I allowed to subtract 2x from both sides? What property would let me do that? Did we do it to both sides? If we do it to both sides and I'm allowed to do it, that would be a property of equality. Subtraction property of equality again. And now I know that this fourth one over would also have to have the same exact solution as the first three. Did anybody solve this one? Let's look at the second one over. What would you do to solve that?
Divide 2.
Divide both sides by 2. So x is what?
2.
2. What happens if I put 2 in for x here? 4 plus 1, which really is 5. What about if I put a 2 in for x here? 4 plus 2 is 6. What about if I put a 2 in for x here? 5 minus 4. What is 5 minus 4? 1. So the first 4 all have the exact same solution. Does this one? What happens if I put 2 in for x here? 4 minus 1 would give me 3, which is not equal to 5. So this one does not have the same solution. That's the only one that didn't have the same solution. All right. What I want you guys to start looking at, page 108 in your book. We'll spend some class time tomorrow actually digging into this. But page 108 in your book is very similar to this right here, in that I've given you 6 different equations. These are slightly more complicated. I want to know, based on the structure, so think about your properties. What am I allowed to do to both sides? Would any of these have the same solution? So one of the best ways to determine without solving is if I can do an operation to one and make it look just like one of the other ones. Sometimes I might need to do 2 operations, as long as I can justify it with properties, right? Mm-hmm.
This one on the board, wasn't that equal to 2x? Because we had minus, so.
Yeah, that one it's got a check mark up above. Yep.
So then what was the
That one you would have to add 1 to both sides. My apologies. You would have to add 1 to both sides there. Because -1 minus 1 would give me -2, so that wouldn't actually cancel.
Really? Oh.
Yep. All right, guys. My promise stands. No homework between now and fall break. Definitely check out pages 106 and 107, though. Have a good one, everybody.